So when we say line items, data is stored in a detailed fashion. So click execute. Click execute. So when I click execute on this T code, KE24, what does it say? This could lead to long runtimes, possibility of several hours. So this is what an SAP has written. First itself they are telling a system response. The response of the system would take several hours. So they are indicating to the consumer that it's going to take several hours. We need to be very patient for this. So what I'm trying to say here is some of the just to read data from tables, if it takes several hours to execute it once, how about if I want to do detailed analysis on data? A question after question, I would like to rapidly fire some questions on the table. Excuse me. So this is what the existing disadvantage that we have in the SAP system. So in order to overcome this disadvantage, I'm going to develop a solution called profitability analysis for HANA, COPA for HANA. So what is the advantage if I can get? Now we know ultimately at the end data will go to COPA. Order is created, delivery is made, from delivery billing is made, from bill data goes to finance, and from here it goes to COPA. So this is nothing but the C1 table. The table that I'm talking here is the C1 IDEA table. We just see the table now. We've just seen the table. So finally, this is one of the table in which the data goes to. Now, once the data goes to this table, what am I trying to do? I'm trying to read data from this table using one T code called K24. When I'm trying to read data from this table, it says possibility of taking several hours to execute a query on this table. So users are unhappy. So to make them happy, I have a solution called HANA. Now we have ECC system over here. We have ECC system over here. So how am I going to design this solution? Let us see. In the ECC system, we have a table called CE1 IDEA. I am actually reading from a program called K24. This report is reading data from this table. So this is the existing process. Now what I'm going to do, I'm going to create a sidecar scenario. I'm going to create sidecar. What is sidecar? I'm going to keep my existing system as it is without disrupting my existing system. I'm going to keep it as it is. I'm going to keep my existing system as it is. And this system is sitting on the database MS SQL. I'm going to create a sidecar. So from this system, I'm going to replicate data to HANA. So business requirement is real-time data. For example, a document is posted to COPA. From sales, from billing, from finance, finally document is posted to this table. Immediately when a posting is done, it needs to transfer to HANA. immediately, within a blink of an eye, just milliseconds. Posting is done, immediately available to HANA. How can we achieve this? Using SLT. So at any point of time, within milliseconds, both the systems are in sync. Whatever the data that you have in this table, we'll also have another copy of table in HANA. So how can we achieve this? How can we maintain a similar table in two different systems? One is on the ECC and the other one in HANA. How can we achieve? Using SLT. SLT is a data provisioning tool that keeps two systems in sync. At any point of time. Whatever the data that you have in this table, it will be same in this table. So what is the advantage? The advantage is this table is row. Once you get this table to HANA, this will be a column table. This table on the MS SQL is sitting in disk, but HANA is a solution that is on the memory. The solution that is designed here is based on ABAP application platform, ABAP application layer. But the solution that is designed over here is in the native HANA. This is on the ABAP app server. The engine that powers this ABAP server, the engine that powers this system is an OLTP system. OLTP, Online Transaction Processing Systems. These systems are optimized to insert data, but not reading this data in an efficient way where it makes the end users happy. It can insert data faster, but to read data, it makes difficult for business users. So these systems are primarily designed in such a way, these are actually good for writing of data, but not for reads. So the engine that can process this data is inefficient to read data. The engines that can process data in these systems are very, very efficient. It uses OLAP, and equally it does OLTP. It can handle transaction processing. Also, it can handle online analytical processing. So these systems are good for transaction as analytical processing, but these systems are optimized for transaction, but not for analytical processing. So primarily I'm trying to give 5 differences: row versus column, disk versus memory, designing the application on ABAP. ABAP does sequential processing. Designing an application on native HANA, it does parallel processing because it uses SQL script. It uses SQL, here it uses ABAP. The engine that processes the data is an OLTP, optimized for insetting of data but not for reads. But these systems are balanced. These are new generation systems that are balancing between transaction processing as well as analytical processing. So at everything that you see, designing the solution is here. It takes for K24, for example, if you have 77,000 records, it would take around to process only 70,000 records. It would take around 40 seconds approximately. The same data when processed here takes 70 milliseconds, less than a second, even less than half second, only 70 milliseconds. Here it takes 40 seconds. Means it is more than 1,000 times slower. These systems are 1,000 times slower when you compare with these systems in processing data. If you have a billion records, it would take more than 5 to 6 hours. We schedule these reports in the background, but here in the foreground, we can just get in 2 to 3 seconds. So performance of reading of data, very time consuming, but very efficient. So using a sidecar scenario, what we can achieve, we can design the solution in HANA in which we can keep the systems to sync. So whenever you have an insert on this table, immediately there's an insert on this table. Instead of designing reports over here, I will design a report over here in the BOBI platform, in the Business Objects Business Intelligence platform, in which I can expose the data models that I'm creating in HANA in different ways where business can consume data. The consumers of data can be exposed to mobile, can be exposed to Excel, can be exposed to PowerPoint, can be exposed to web, can be exposed on cloud, can be exposed on designing a solution on HTML, can be exposed to Fiori. So there are different ways that you can consume data on a single data model. Only one data model can be consumed in different ways, and also at last the third-party systems like IBM, Cognos, Tableau, TIBCO, Spotfire. I can use different systems to consume a single data model. So HANA has a flexibility in exposing these data models not only to SAP, not only for analytical solutions, but a very, very tight integration with third-party solutions. So here, the typical ABAP report. So it is something like this. Very, very inflexible, not at all flexible, and not at all user-friendly. But these systems were very good. These systems are really very good 10 years back. But the way now the business is conducted, now these are the way the reports are there in two-dimensional models, in two-dimensional reporting. Now we can conduct reports in multi-dimensional fashion. It is reading the 77,679 records. So if you see S11, the same record, 77,675 records in a table. The same number of entries are being read in this report. Display actual line items. The T code is K24. So it's basically displaying us based on company code, based on customer, based on product, based on company code, what is my revenue, what is my labor cost, production variance, what is my contribution margin, what are my margins. All this is displayed in this report. Okay, finally, I just want to conclude this topic. Now we know why we want to go for HANA. All that I'm trying to explain now, I'm just trying to explain why we need HANA for this solution. Because first of all, the volume of data, the way the data is stored, the way the data is processed, the way the data is presented. In every single way, HANA is a super solution. So once we actually design this in HANA, users are very, very happy. Because first of all, engines are faster. The modeling is faster because here we have to write ABAP code. Here we do model to code. We generate model, system generates the code. But here it is code to model. We write code, system generates the model. Opposite of what we do over here is HANA. It's very easy. Basically, it's very easy in terms of development, in terms of maintenance, in terms of how the end users can interact system. It's very, very simple when you compare with the complex system that we have. Okay, now one I'm talking about the flexibility that users can consume data using mobile, using cloud, using client, using Excel, using web. So here it gives for business self-service BI, self-service. They can service their own reports. We just give the data model to them. Okay, this is the data model I've designed. Now you can consume this data model in the way that you want. So here it is not self-service, but we need to create layouts, templates for users to view. Even they can also do it. Excuse me. So even they can also do it, but this is mostly self-driven. Users can design their own reports. So that is the reason I want to design the solution in HANA. Now we know we have an existing ECC. We want to buy a new solution called HANA. But if we want to have this solution design, next thing is how I can purchase HANA now. How do I purchase HANA? Now HANA database is available in a standard 3 licensing models. One is known as Enterprise Edition. One is known as Platform Edition. The other one is known as Enterprise Extended Edition. So the first one is Platform Edition. The second one is Enterprise Edition. And the third one is Enterprise Extended Edition. So what is the difference between these three? Platform Edition, when you purchase a Platform Edition, we only get database. Means if we only get database, how can we keep both these systems in sync? Because whatever the data that is generated over here, I also want to keep in the system. To keep both the systems in sync, always same, we need SLT. So SLT will not be available as a part of Platform Edition because you only can purchase a database but not the data provisioning tool. You cannot purchase data provisioning tool. So in order to purchase this data provisioning tool, we need to go for Enterprise Edition. So in an Enterprise Edition, you can get data provisioning tool and you can get HANA. So you have another solution, Enterprise Extended Edition. In an Enterprise Extended Edition, you can get SLT, you can get BODS, you can get SRS, Sybase Replication Server. Sybase Replication Server is for high availability disaster recovery. Sybase Replication Server for high availability disaster recovery. So that is a different kind of tool again. So in order to achieve this solution, I require Enterprise Edition. When you purchase an Enterprise Edition, we get HANA, we get SLT, we get BODS as a part of this license. So now we know we want to go for Enterprise Edition. Now SAP or SAP partner has implemented HANA. We implemented SLT. Now systems are ready to be used. So later I will show you how to install HANA, how we can configure SLT, how we can interact with the system at a later point of time. But now I'm just focusing on the data modeling aspect. So now what is my requirement here? Now by actually created this Sidecar scenario, whatever I have data over here, I can get to HANA. Okay. Now I know I can start working on COPA. My system is ready. I configured system, I install HANA, I configured SLT, and all these three systems are up and running and integrated to each other. Now let us discuss about business. Now we know what is the advantage of using HANA, but what is the advantage of using COPA on HANA? Now let us see from COPA point of view, controlling profitability analysis. Now we know every enterprise has a different way to do business. IBM has a different way to do business. Accenture has a different way to do business. SAP has a different way to do business. Even me at Surya Academy is a different way to do business. Different institutes have a different data. I mean, the way they conduct their business operations are different from one business to another business. We rarely can find two businesses similar way they can operate, take decisions, create business models, do operations. So it's very rare. The point I'm trying to highlight over here is the way we conduct business is unique. So SAP, when we create these enterprise structures in SAP, these enterprise structures are nothing but also known as operating concern. It's known as operating concern. Technically, this is known as operating concern, generally called as enterprise structure. Every business has a different enterprise structure. Means how they operate business is different, so the enterprise structure would be different. So the operating concern would be different. SAP has given a standard template. SAP has given a standard template. Like for example, you have operating concern on the top. Under operating concern, for example, this is Tata group of companies, for example. Tata operates lot of business, from steel to automobile, from consumer business to electronics. So they operate most of their businesses. So Tata is one company, so they have a group of companies. So under Tata, you have controlling areas. This I'm little explaining on the business scenario at which we will be working on HANA. You're trying to understand business process. So operating concern, under operating concern, we have controlling areas. And each controlling area, you may have different company codes. And each company code, you have different sales organizations, sectors, divisions, distribution channels, and so on. So operating concern, controlling area, sales organizations, distribution channels, like this, an enterprise structure would be defined. Now, whose responsibility is to design this enterprise structure? This is the responsibility of a FI consultant. So FI consultant, the consultant who is working in FI, will design. So this is my way they can operate my business. So FI consultant creates an enterprise structure. Once this enterprise structure is created, now we know we have seen different standard tables in SAP. Until now, we have seen KNA1 is a table which store customer data. MARA is a table which store material data. T005T which store country data. T001 which store company code related data. So all these are standard tables that are provided by SAP. So they have a structure which is provided by SAP, but still we can enhance based on my requirement. I can do the enhancing of this. So in a similar fashion, for an enterprise structure, SAP even did not give a standard table. Excuse me. Like how these standard tables are given, SAP did not give any standard table for enterprise structure. So these are generated tables. Now why these are generated tables is because we know the enterprise structure is not constant. It changes from business to business. And then if the enterprise structure changes, then how will my tables be standard? So based on the enterprise structure, the point I'm trying to make here is, based on the enterprise structure, there is no standard table. But SAP has given a naming convention on how these tables can be generated. They told, okay, you can start the tables with CE1, XXXX. You can start these tables like this, CE to XXXX. Like how we have KNA1, like this they have given some standard tables. So for COPA, these are some of the important tables in which COPA data is stored. So how these tables are generated? These tables are generated when I generate an enterprise structure. So whose responsibility is to create an enterprise structure? FI consultant. So when FI consultant creates an enterprise structure, because the enterprise structure can change, based on the definition of the enterprise structure, these tables are created. So in these tables, I store my COPA data. So what is my requirement over here is, these tables are available on the ECC system. These tables are available in the ECC system. Means these tables are available on the ECC system here. So these tables I need to move via SLT to HANA. So my requirement is, on the ECC system, whatever the COPA tables that are generated based on the operating concern, these tables I move using SLT via SLT to HANA system. So first requirement is based on the business, identify what tables you require and replicate the tables using SLT to HANA. That is my requirement. So how these tables are generated? By FI consultant. Now what I'm going to do these tables, I'm going to replicate to HANA system. Is these tables standard or generated tables? Generated tables. These are standard tables. Now let us try to understand what are these tables and why we need to use these tables and how these tables are advantageous to move to HANA. Let us try to understand this. So now I have these tables. XXXX is known as operating concern. If I give a name for an operating concern called Tata, what would be my table names? My table names would be CE1 Tata, CE2 Tata, CE3 Tata, CE4 Tata. XXXX is nothing but an operating concern. If an operating concern is a Tata, then the table names will be CE1 Tata, CE2 Tata, CE3 Tata, and CE4 Tata. What is the C1 Tata? C1 Tata is a table that stores my actual COPA data. CE2 table stores plan COPA data. C3 table stores summary of COPA data. Summary table means aggregated table. CE1 and CE2 are both line item tables, are both line item. When we say line item means detail, the granularity in which the data is stored. Granularity is nothing but the detailness in which the data is stored and the summary level. So it basically the data is stored on a summary level. And CE4 stores master data. Stores the master data. Now, what tables do we require? What tables do we require to build this COPA application? What tables do we require to build this COPA application? C1 Tata, C2 Tata, C3 Tata, and C4 Tata. So the main tables I require is these two tables. One stores actual, the other one store plan. Now why I don't require C3 table, which is summary table? Okay. If you see the architecture of ECC, you have tables that store line item, you have tables that store summary table. Now why we are storing this data like this here? Because if I ask a question, something like this. Can you give me net revenue? Can you give me net revenue based on a material? I'm asking a question. Can you give me net revenue based on a single material? For example, I'm selling Apple laptops. So what is my net revenue based on Apple laptops? Only based on a single material. Next question I can ask is, can you give me net revenue based on this period, based on this month. Net revenue based on a month for Apple laptops. So in the whole month, can you give me net revenue based on Apple laptops? Can you give me Apple laptop today, yesterday, day before yesterday on a daily basis, in a monthly basis? So all the purchases that I made in a month to sell Apple laptops, based on all the purchases I made in a month, I'm going to cumulate, I'm going to sum up. Let's say for each Apple laptop, I get 1000 INR. Every day I sell one laptop, I get every day 1000 INR. So in a month, for example, 31 days, I get 31,000 rupees. So now I can ask the same question over here, the C1 table. But how many items will I find here? To get 31,000, I need to analyze 31 records. Every day I sell one laptop. So to analyze my contribution margin, sorry, not my contribution margin, to analyze my net revenue. To analyze my net revenue for a laptop in a month, I need to go to 31 records. But these 31 records are accumulated, something like this. Apple laptop for the month of Jan, it is 31,000. So it is pre-calculated, it is already calculated and stored in this table. It's stored something like this. For this period Jan, for this material Apple laptop Pro model, 31,000 is my net revenue, which is already pre-calculated and kept in this table. And the other way I can produce this result is I can go to all these 31 entries. When I execute a select statement, at that point of time it will calculate. Now please tell me, when I execute a report, it goes to all these 31 records, it goes to each record, gets 1000 value. For 31 records, 1000 plus 1000 plus 1000, it calculates. When the user is actually executing a report and then give the result back. To produce this calculation, it is very inefficient in these systems because the engine that processes this data is an OLTP engine. It's very inefficient to process this data because it has to accumulate 31 entries in each table. But here, because this engine is inefficient, I pre-calculate data and store in this table, which is called a summary table, which is known as a summary table, which is already pre-calculated. Now, why did I pre-calculate? Because the engine that process is not good for aggregations. The question here is, now why I don't require CE3 in HANA? That is the question here. Why I don't require? The answer is because HANA has an OLAP engine. What is the advantage of having OLAP? Faster aggregation, mass aggregation of data. It does mass aggregation. How fast it can do mass aggregation? It can 15 to 30 million aggregations per second per core. One core in a CPU can process 15 to 30 million aggregations per second per core. So that is the reason I don't have to again move CE3 table to HANA, because the same 31 entries I have in this table is very fast when I execute a report. At the same speed, it can give line item reports. At the same speed, it can produce an aggregated report. The same summary I can do when I ask a question on the fly because engines are very powerful. Because engines are not powerful over here, I have to maintain two tables. One of the table can maintain line item, the other table can maintain detail. Line item, the other table can maintain pre-calculated data is stored. Means this is an additional table and an additional step. I require maintenance. I'm wasting my time to maintain this table. So here I have only one table. Here I can do whatever I want in this single table, whether I want to read line item table or a summary table. Okay. So I'm going back to my, so we are trying to understand the important tables in COPA, C1, C2, C3, C4, C1 for actual, C2 for plan line item. This is for plan line item, plan line item, plan data, plan COPA data, CE2. Summary table. So I don't require summary tables. I require line item tables. On the line item itself, analytic views. Analytic views are multi-dimensional views which execute on OLAP engine. OLAP engine is optimized for mass aggregation of data. How fast it can aggregate 15 to 30 million aggregations per second per core. Analytic views are very efficient in processing data parallelly. Massive parallel processing can be executed on analytic views. The way data is stored in memory, the way the data is stored in column, the way the data is processed is an OLAP engine. The way the CPU process data is very efficient in dividing this data in multiple smaller subsections, and each section of data is processed in different CPUs. Each CPU can process 15 to 30 million aggregations per second per core. Okay, finally, what I'm trying to conclude here is I don't require summary tables to maintain in HANA. I require only line item tables. On a line item, I can do on the fly aggregation because the engine is very efficient and the hardware to process this engine is very efficient. So when I move tables via SLT, I require only CE1 and CE2 because I can do on the fly aggregation. Now, what is this actual and plan? What is this actual and plan? Actual data, when we say actual, what does this mean? When we say plan, what does this mean? Suppose say I want to travel to Delhi. I want to travel to Delhi for a business meeting. So when I want to travel to Delhi, I plan my expenses. Okay. The expenses I plan, I require 20,000 INR for a 3-day trip in Delhi. This is my plan. My plan is I require 20,000 INR. So what is my plan? My plan is require 20,000 INR to plan my expenses in Delhi. But once I return back from Delhi, I went to Delhi, I returned back. Once I return back, my actual expenditure is only 10,000. Is only 10,000 INR. When I'm going to Delhi, I took 20,000 rupees. When I came back from Delhi, I spent 10,000 and I have 10,000 rupees with me. So this is my variance. Plan minus actual gives you the variance, which is 10,000 INR, is my savings. So even in business, we need to plan. We plan for materials, we plan for customers, targets that we have to achieve in this particular quarter. And these targets are distributed down to every sales office, every distribution channel, every company code. The targets that we fix is distributed down to a very low level. To what target? How many laptops does this sales representative has to sell this month? The sales representative has to sell 10 laptops as his target. So every customer who comes into this, every customer who comes into his shop, he has to convince that customer to buy his laptop or to buy the laptop. So what I'm trying to say over here is we fix these targets and these are captured in plant data and these are actuals. Simply to say, if I achieve my target, if every sales representative achieve the target, obviously I'm in profit. If a sales representative did not achieve, then I'm in loss. So this is what a COPA can do. Based on each materials like laptop, what customers are purchasing, what is my net revenue, what is my gross revenue, what are my deductions, what are my contribution margins, what is my production labor. All these kinds of analysis you can do in COPA. And you can take key decision making to improve your profitability analysis. This is what a COPA can do. And you can take decisions very efficiently in a very faster way, in a multi-dimensional fashion. Now coming to linking of analytic views. So of all these things, how this is related to analytic views, let us do a comparison. So first we talked about what is the advantage of HANA, why we have to move data using SLT from ECC to HANA, what are these tables, how these tables are generated, what is the use of each table, what are the tables I don't require, what is that I am doing with COPA, and finally, how I am going to relate all these topics to analytic views. Analytic views are multi-dimensional data models. Analytic views are multi-dimensional data models. Analytic views are multi-dimensional data models which are in the form of star. Star means star schema. What is a star schema? What is a schema? Schema, nothing but group of tables or group of database objects. A schema represented in a form of star is known as star schema. Representation of tables in a form of star means you have KNA1 table, you have MARA table, you have T001 table, company code, you have time dimension tables, and then in the center you have a fact table. So all these different tables represented in a form of star for doing multi-dimensional analysis. A dimension is nothing but the perspective in which you would like to analyze data. In what perspective? You want to analyze based on customer? What are my top customers? What are my slow selling materials? What is my net revenue based on this quarter? What are my sales based on each company code? At what dimension you would like to analyze? You can do a multi-dimensional analysis. Any dimension, whether it could be a single dimension or it could be a customer purchasing what materials, and these materials are purchased from what company code, And these company codes, can you show me based on this week? A multi-dimensional question which spans across all the dimensions. And this star schema is executed on a very powerful engine called as OLAP engine. What is the advantage of OLAP engine? Mass aggregation. It does mass aggregation of 30 to 15 to 30 million aggregations, and it does massively parallel processing of data. So the fact table that I'm using over here, the fact table is nothing but the CE1. If I want to do my profitability analysis based on actuals, I'm going to use CE1 table. If I want to do my analysis on plan, I'm going to use CE2 table. So an analytic view is a multi-dimensional view represented in a form of star schema. A schema is nothing but collection of tables in a form of star. This gives advantage of analyzing data based on multiple dimensions. A dimension is a perspective in which we could analyze data. You can analyze data based on multiple dimensions. This star schema, this analytic view, executes on OLAP engine. OLAP engine is optimized for mass aggregation and massively parallel processing of data. By analyzing the data in a very faster, very efficient way, business is very happy in terms of response, in the way they want to consume data, in very, very easy manner, in a very, very simplified manner. So now these systems are designed in such a way to keep business very happy in terms of consuming this information and taking better decision making in a very flexible and simplified process. That is the advantage of analytic view from business point of view. So just to conclude this session for today, I'll just repeat what we have learned in this session. Excuse me. So in today's session, we started to understand what is an analytic view. Analytic views are multi-dimensional views. In the center, they have the fact table. Fact table consists of measures. Measures are related to amount and quantity related data. Fact table in the center, surrounded by dimension tables, is nothing but represented in the form of star schema. The advantage of analyzing data in a star schema, you can do multi-dimensional analysis. Analytic views execute on OLAP and can do parallel processing of data. That is the definition of an analytic view. Why we have to use COPA to design an analytic view? The disadvantage of the existing system maintaining data redundantly. The engines that process data, the way they store data on disk, the way ABAP process data is very inefficient. So we move these tables and data via SLT, SAP Landscape Transformation. It is used for real-time transfer of data to HANA. Once the data is transferred in real time to HANA, we build data models We build multi-dimensional data models. And these data models we execute on these powerful engines. Whenever an enterprise structure is generated by an FI consultant, there are 4 tables that are generated: C1, 2, 3, and 4. We don't require aggregated tables because HANA can do on-the-fly aggregation. C1 and C2 tables are generated when you generate enterprise structure. These tables I replicate to HANA, and these tables I'll use them as a fact tables when I create an analytic view. So the final point, there is only one point that we have to learn here is CE1 data table or an IDA table we will use inside an analytic view because this table contains transaction data. We have to move this like how we have KNA1, how we have Mara. C1 table is a table that stores transaction data. We require this table when creating an analytic view. Now we know how this table is generated, what is the importance of this table, and why we have to create data model for this table in HANA. Because of performance. So that is for today's session. Participants may have any questions. Please type in your questions in the chat box. I'm going to read your questions and answer your questions. Thank you. So there are a few questions over here. Considering CE3XX tables are not required in HANA, is this the same reason why such as BSIS not required in S4 HANA? Yes, correct. So we don't require index tables or aggregated tables where we simplify the way the data is stored, in which it improves the overall return over investment. Are analytic views used only for finance related tables? No, they can be used for any application. But here I'm trying to analyze finance, but for the assignments that you will do, they are based on sales. So you can also use sales tables and you can create analytic views, and that will be the part of the assignments. I already uploaded the first assignments in the Dropbox. So this will be the part of second assignment. For COPA, you are using telling with examples for sidecar scenario. But how about main car scenario? For the main car, it is same, but only for designing COPA. If you go for main car, it means that your entire ECC system is on HANA. Entire. But technically, if you ask me what is the difference, then I would say no SLT required. Because application itself is getting data from ECC. But still, you have C3 tables which are sitting in HANA. So the disadvantage of going for a main car, if you are not entirely utilizing the HANA system, the cost that is associated to maintain these tables. Because suppose say we require only 100 tables, but now when you have ECC on HANA, you'll have all the million tables on HANA. So if you take an advantage, go for main car. If you have small set of reporting or small applications to be delivered, then go for a sidecar scenario. This is only for cost. Others technically it is same. So I'm unable to get the server access. It's throwing an error. 1 minute. Okay, I think the internet, where the servers are located, there is there is a work going on from the Airtel. So Airtel is working on that. I came to know that they're digging something over there. Means I don't know for what they're digging, but some lines or something they're digging. It seems that's why there is a disconnection. So probably by 11 or so, again it will be up. So this is not from our side, but unfortunately this is affecting our work. So this is from, so we have Airtel connection, servers are in India. So there's some work going on. So they actually told us, I think by 11 it should be up. Surely I'll keep follow up with the Airtel. I'll ask Bharat again about this, what is the status. I'll ask Bharat to post you on the same. Thank you. Next question. Is there any performance issues when you're going for main car because there will be a million tables, so there would be any possibility of performance issues? So we have to size correctly. When you do the sizing correctly, when you're sizing the system correctly, you have appropriate cores, you have appropriate RAM, and then you have, when you do the sizing correctly, there would not be performance. Unless and until your sizing is correct, either for side car or main car, we will size appropriately. And we need to follow the best practices in creating data models. Even we have performance issues, even if so, we can do, root cause analysis, whether it is from a hardware side, whether it is from program, or whether it is from database, whether it is from network. Sometimes network also create performance. The server is fine, data models are fine, but when you send the request, so we'll try to do root cause analysis on this from database, from the application, from the user interface, the user in which they're accessing the data. We'll try to do the root cause analysis, and if it is from hardware side, then obviously we need to scale up the hardware. We need to scale up the hardware to give appropriate performance on the system. We can add RAM, we can add CPUs in the existing system. So next question, is there any tool for doing root cause analysis? We have visualize plan. There's a tool called Visualize Plan. It's an option in HANA. It'll actually tell you where actually the performance issue is coming from the database point of view. You can use Visualize Plan. We'll see the tool. So once we complete data modeling, right, I'll show you how we can use the tool. Yeah, I'm here, I'm here. I'm here. Any other questions? Participants may type in your questions, please. Thank you, everyone. These are the questions in the chat box. Thank you, everyone, to attend today's session. So in tomorrow, what we will see is how to create these analytic views. We'll see how we can do the navigation part on these analytic views, and we will see the output of the analytic view in tomorrow's session. Thank you, everyone. Have a nice day. Good evening and good morning to everyone. See you tomorrow. Thank you.